In Chapter 6, although it's called Further Calculus, and the focus is calculus, differentiating and integrating, I guess really, to me, it seems to have 3 parts. It's not a very long chapter. We're only looking at 6 exercises. 2 of them are on further calculus, differentiating and integrating, of trig functions. And so we're going to look at, because we've already looked at differentiating sine, cos and tan, we're going to look at the inverse functions, cosec, sec and cot. Then, and that could have been done in the trig chapters. Exercises then, the next 2 are really integration. So it could have been covered in integration. And I think we did just touch on this, integration by substitution. But remember me saying that we'll go into more detail about exactly, perfecting that method of integration later. And then actually there are only 5 exercises, not 6, that we'll do. 6E is this very different concept altogether, and it does involve calculus, but it's more about finding where a graph cuts the x-axis, finding the roots of a function, if we were graphing it, where the graph cuts the x-axis. So that's very different, because it may not be a trig function, it's not about integration, it's actually about differentiation. So 3 different, very different concepts we're going to cover. And we could start at 6E. There's nothing in 6A, B, and C and D that we would need to know about before we could do 6E. So they're really quite independent concepts. Okay, I prefer to call it the bits and pieces chapter. And you might prefer to take aspects of chapter 6 and put it with previous topics, like you might take this trig work and put it with your previous chapters. Integration, same, you might put this 6C and D in with your integration notes. And these will stand alone, and they will be, they're named, these methods. So we're looking at alternate methods, finding the roots of a function. I think you'll just learn them under their names. And the questions testing that will be fairly obvious. Okay, so in 6A, we're differentiating. Well, it does say the 6 trig functions, but you've already done 3 of them. You know how to differentiate sine, cos and tan. And so we're really focusing now on cosec, sec and cot. So let's have a think about differentiating cosec. The textbook suggests you learn the result of the derivative of cosec off by heart. If you're good at learning things off by heart, and you don't feel you already have enough that you have to learn, then I might suggest that you wouldn't really need to. You can actually derive it. It's not a long process, and it just reinforces some really good both techniques and previous learning. So you've already got the previous learning. Let's use it to actually differentiate cosec x. So we're just going to be using the chain rule. We're going to write, obviously, cosec x as 1 on sine. Now that makes sense because we know how to differentiate sine. But before we do, we might take sine of x out of there and write it with its power. Why? Because we know how to differentiate something to a given power. We bring the power to the front, subtract 1 from the power, and using the chain rule, we differentiate sine and we get cos. So really the derivative of cosec x could be written in this format. Now that's not the format that the textbook shows, but let's just go on to see why this is correct and it looks different, we're going to break minus sine of x to the minus 2 up into, well, we know sine of x to the minus 2 is 1 over, okay, I'll just write that. Sine of x to the minus 2 on its own would be 1 over sine x squared, sine x times sine x. So actually, if we think of it as sine x to the minus 2 as 1 on sine x, actually I'll write that as times 1 on sine of x. Then you can see this one of them is sitting there. This other sine x is sitting there, and I've coupled it up with the cos x. Why? Because we've got a name for, and we just keep the negative going. Don't lose that negative. Keep that negative going. Sine of it, 1 on sine x is called cosec x, and cos on sine is called cot. So that is what the textbook is suggesting you learn off by heart, whereas just in case you might get that, or it's just another thing you don't want to have to learn off by heart, then you don't need to. It's nothing difficult, nor is it new. You know how to use the chain rule. You know your understanding of cosec. You know your understanding of differentiating a negative power. You know how to differentiate sine to simply get cos. Then you're just rearranging it. And it's never a bad thing to revise your negative power work, even just fraction work. It's not a bad thing. And to manipulate your trig ratios to form other trig ratios. Well, we do that. We often do that in a show or a prove question. Now, rather than go through the proofs or demonstrate how you can differentiate or why the derivative of sec and cot are what the textbook suggests, I'm just going to go straight to examples involving cot, as you can see there, and the next one is about sec, and have a look at how we would differentiate this. So if you're going to learn what's in the textbook off by heart, you can come up with your answer straight away. Otherwise, you'll be doing it this way with nothing further to learn other than the things you already know. Because we know that cot is equal to cos on sine, then we can write cot as cos on sine. Now, if I was differentiating this, what do I see? I see a fraction, a quotient. So what I can do is I would label the top as u, cos of 1 minus x, and there's nothing difficult about differentiating a cos. We know how to differentiate cos. The moment you introduce cos and sine, you know how to differentiate those. You've learnt those. So cos goes to sine of 1 minus x, and differentiating the x function, so it will actually be a negative. V, on the other hand, is the sine of, hang on. Yes, let me correct that. Differentiating cos goes to minus sine, so we should have a minus there. And then inside the bracket, differentiating the x is a minus, so that turns back to the positive. V is our sine. Differentiating sine goes to cos without that minus, but differentiating within the bracket puts the minus at the front. Okay, now we're going to use our quotient rule. And please be careful writing the quotient rule. I'm still seeing students not writing that down correctly. So it's vu squared minus uv squared on v squared, subbing in, so we're getting sine times a sine and a minus, obviously, and a cos times a minus cos, which now hopefully you can see on that top line, this goes to sine squared. Sine times sine of the same thing is sine squared. The negative and the negative give a positive. Now, the moment you see sine squared and a plus and a cos squared, sine squared plus cos squared of anything is 1. Sine squared plus cos squared is 1. So the top line goes to 1, square the v, and 1 over sine squared is called cosec squared. You might just wonder what happened to the minus if you're looking at the rule from the textbook that says d dx of cot x is minus cosec, and so you're wondering why we don't have a minus. The reason we don't have a minus is because of that minus inside there. Had to be differentiated as well, and when that was differentiated, it cancelled out the negative from the rule. So I don't know if some of you who are just learning the rule might have got caught out on that, and I guess that's another reason not to go with the rule as it's written in the textbook. Rather work through it yourself. And now in the second example, we're actually going to see the derivative of the sec trig function. Because this is saying find the gradient on the curve. We know that if we differentiate the function, we get an expression for the gradient, and we know the particular point. So our expression will have an x in it. We will sub our x value in to actually find the value of the gradient. But first step is, of course, to find the gradient. So writing y as sec 2x in the format sec is 1 on cos, and then we will write it in our powered form, and we know then to differentiate we bring the power to the front and we subtract 1 from the power, so we'll go to a -2. And we've got a few things to multiply by. Within here, we've got to multiply by the derivative of cos of 2x. The derivative of cos is minus sine 2x, and we further have to differentiate the x, and differentiating 2x, we get a 2. Now the negative and the negative make a positive 2. Sine 2x is on the top, and cos 2x, all squared, goes to the denominator. Now that's not the format that it appears as in the textbook. You can probably see that what they've done, and they don't have a 2 because they're simply showing the derivative of sec of x. We need the 2. So I think they've broken up the cos 2 of x all squared into one lot of cos 2x, and we have to have another one in the denominator, but they've paired it up with the sine of 2x over the cos of 2x. So hopefully you can see that that is 1 on cos is sec 2x, and sine on cos is tan 2x. And that's more the format of what they have. They've got their sec of x and tan of x. But keep in mind, we've got the complication of the 2x, so we've got to make the adjustment. You should be right now to do exercise 6A.